This video presents an overview of the chi-square test of association. A study was done to determine whether there was a relationship between eye and hand laterality. The dominant hand and eye were recorded for each of 413 randomly sampled undergraduate students. This study involves two categorical variables, and the appropriate test is the chi-square test of association. The null hypothesis is that there is no association between the two variables, and the research hypothesis is that there is an association. The assumptions are the same as for the goodness of fit test, but applied to two variables. This was a random sample, and one student's hand or eye dominance does not influence another's, so the observations are independent. The mutually exclusive and collectively exhaustive categories assumption is also met for both variables. All subjects are either left-handed, right-handed, or ambidextrous, and have either a dominant right eye, dominant left eye, or are ambiocular. The large expected frequencies assumption applies to all cells. To determine the expected frequencies, we multiply the row total for each cell by its column total and divide by the total sample size. Applying the formula to the first cell, we would expect 35.4 left-handed, left-eyed subjects if there were no relationship between eye and hand laterality. The large expected frequencies assumption is met. There are 3 rows and 3 columns, so 4 degrees of freedom. We'll set the significance level at 0.05 and go to the table to determine the critical value of the test statistic, which is 9.488. The chi-square formula is the same as for the goodness of fit test. Applying it to the data, we get a value of 4.02, so the null hypothesis is not rejected. Here's what the SPSS output looks like. This is the cross-tabulation of hand and eye laterality with the frequencies for each cell. The chi-square table looks a little different than for the goodness of fit test. Notice that there are several test results listed. We interpret the first row, the Pearson chi-square result. The researchers would conclude that there is no significant association between hand and eye laterality. Because the null hypothesis was not rejected, no further analysis is done. Another study examined predictors of condom use in a random sample of unmarried multi-ethnic San Franciscans. Here are the data for the relationship between sexual orientation and condom use among men. The null hypothesis is that there is no association between the two variables, and the research hypothesis is that there is an association. The expected frequency for each cell is greater than 5, so the large expected frequencies assumption has been met. This study used random sampling, and interviews were done privately, so responses can be considered to be independent of one another. Categories for each variable are also both mutually exclusive and collectively exhaustive, and the sample size assumption has been met. The researchers used a significance level of 0.05, and there are 2 degrees of freedom. So the critical value of the test statistic is 5.991. Let's look at the test results. The p-value is very small, so we reject the null hypothesis of no association. The researchers conclude that there is a significant association between sexual orientation and condom use. They would look further to determine the nature of this association. They must first identify the explanatory variable. If one of the variables can be considered an independent variable, or predictor, this would be considered the explanatory variable. You can also ask whether there is a dependent or outcome variable. You would compare percentages by the other variable. You can also ask which came first. If there is a clear answer to this question, then compare the percentages based on this variable. In some cases, there will be no clear explanatory variable. For example, if the results had been significant for the hand and eye laterality study, the researchers could probably choose either variable as explanatory. In the current study, it is safe to assume that sexual orientation preceded condom use, so we will take this as the explanatory variable. To get at the nature of the relationship, we go to the cell display menu in crosstabs and ask for percentages by the explanatory variable. We also request both observed and expected frequencies. The z-test is used to compare the proportions across the sexual orientation categories. We can get a sense of where the differences are by comparing the expected and observed count for each level of condom use. For the never category, there is a lower than expected number of gay and bisexual respondents, whereas a higher than expected number of heterosexual respondents fall into this category. The opposite trend occurs for the always category, and there doesn't seem to be much difference for either group in the sometimes category. Comparing percentages for each condom use category is also informative. For example, we can see that a larger percentage of heterosexual men compared to gay or bisexual men report never using a condom. However, we formalize our interpretation of findings by relying on the z-test results. We asked for percentages by the explanatory variable, sexual orientation. This is the column variable, so each column will sum to 100%. The footnote at the bottom of the table provides a guide to interpreting these results. There are different letters next to the cell counts for the never and always condom use categories, so there is a significant difference between gay and bisexual men and heterosexual men for these categories. The same letter appears next to the cell counts for the sometimes category, so there is no difference for this category of condom use, and they would write up this interpretation accordingly. Chi-square test results only tell us the likelihood of dealing with a chance event. They do not tell us anything about the strength of the association. For this, we need to ask for measures of effect size. Kramer's V is a correlation coefficient and is interpreted using Cohen's conventions. This value falls in the moderate range, meaning that there is a moderate relationship between sexual orientation and condom use. This value can be squared to provide a measure of shared variance. 17% of the variance in condom use can be explained by or attributed to sexual orientation, leaving other factors to account for over 80% of the variability in condom use. Let's look at the chi-square results table more closely. 3 different statistical tests are reported. Generally, we interpret the first row. So what are these other 2 tests, and when are they used? The likelihood ratio is used when the sample size is small, that is, when the expected frequencies assumption is not met. The linear bilinear test is sometimes used to examine trends for ordinal data. For example, if we measured age and income on ordinal scales, this test could be used to determine if income increases as age increases. This test is also used with 2x2 tables, that is, when each variable consists of only 2 categories. All of these are chi-square tests, so they are all chi-square values. Correlation does not imply causation. Finding a significant relationship between 2 variables does not necessarily mean that one causes differences in the other. In the previous study, it is likely that gay and bisexual men are more aware of health risks or more likely to perceive a risk of HIV transmission, and that this awareness results in higher condom use. An obvious example of correlation versus causation is the relationship between the number of firefighters on the scene of a fire and the amount of property damage. This doesn't mean that we would hope fewer firefighters show up at our house if it's on fire. More serious fires require more firefighters and result in more property damage. Chi-square tests of association examine the association or relationship between 2 categorical variables. If results are statistically significant, we do further testing to determine the nature of the association. We can also use Kramer's V as a test of strength of association.